Tanmoy Biswas, I welcome you all in my channel Chemistry the Mystery of Molecules. So today's topic is a little unique as well as interesting because we shall discuss today about CO2 separation, excess CO2 separation from here and its background. Actually this video is mainly will be a brief version of many important topics, so please don't get disappointed. I shall explain every topic in future videos in details. So let's learn. So now the most important question will come in our mind: is CO2 good or bad, or do we really need CO2? Obviously CO2 is not bad. Actually excess of CO2 in the atmosphere is bad, fine, because we need CO2 for plants, because the plant eats CO2 and produces glucose via photosynthesis, and so in this way food is produced. Second, CO2 is important because it prevents Earth from losing its heat, because during the daytime Earth gets heated and in the night time the reflected heat from Earth is stored because of CO2. This is called global warming, means actually not global warming because it is a greenhouse effect. Okay, so that's why our Earth is warm throughout the day and night, but if it absent this CO2, then our Earth would have been frozen during the night time. Now, but the problem actually is because of the excess CO2 which results this global warming, means the globe is getting warmed compared to what? Pre-industrial state, and that's creating lots of problems, climate calamities, etc. Okay, so as a result what may happen, that sea level may increase. How? Because the polar ice, if the average temperature of the globe increases, the polar ice or glacial ice will melt and the sea level will increase and it will grab many usable lands. Point number one. Second, it can create lots of freshwater crisis, because the glacier are one of the main source of fresh water in our planet. So if those glaciers become shorter or smaller, then freshwater supply will be shrinks. Additionally, this global warming will result in change in climate pattern or abnormal weather pattern, you can say, and this will create a lots of problem in global food production, which ultimately even result in climate refugees. So like our food security, others like food security, water security, we should consider this climate in a form of climate security. Now, so why the main reason for excess CO2 in the atmosphere compared to the pre-industrial level? The most important reason is the deforestation for agricultural and human settlement, because the earth was previously a big jungle. So because of human settlement we have destroyed those forests, and this destruction have reached a limit which is destructive for human civilization. Because of this excess CO2, because only plants eat CO2, we can't eat CO2. Okay, you will say that's our Coca-Cola bottles or this cold water, this thing needs CO2. Obviously true, you drink CO2, but that's a very minimum compared to how much we are emitting every day. Okay, even petroleum industry needed for excess oil recovery CO2, but those are very less compared to overall emission which is caused by excessive consumption of fossil fuel like burning of coal, petroleum and natural gas for our energy generation. Actually this is because of mainly electricity generation as well as temperature. And remember student, our majority of energy demand is fulfilled by this coal, petroleum or natural gas. You can say there are nuclear, wind, solar, but those are limited. Okay, so that's the issue, means adequate infrastructure is not available for those renewable energy sources and its utilization. And the most important or the saddest thing is that lack of awareness as well as political interest. That's why country don't take policy for the CO2 reduction, even they don't follow the Paris Climate Agreement properly, which will come later on. So we should remember one statement: the earth is not only for humans, it is for all. So if we destroy other creatures, destroy the ecosystem of earth will take revenge and restore its original thing by destroying or killing many humans. So we must be careful as soon as possible. Now, so what is the natural way to fix CO2? The natural there are two kinds of way. One is temporary way and one is permanent. So temporary way, you can say that agriculture consumes CO2 in the atmosphere by photosynthesis and producing food. For example, this glucose C6H12O6, from where it produced from CO2. Now from there other agricultural material are produced. This is the first CO2 fixation reaction, and I would say this is the most efficient CO2 fixation. But for example, you have synthesized a crop, how long you will store? Maybe 1 year, 2 year, like that. Apart, if you don't store it properly, after that it will be degraded automatically. So after that it will be converted into CO2. So we consider 1 year, 2 year, maybe using very special technique you can go up to 5 years, but I'm not for a long term. Okay, so this is a short term CO2. After that this thing will degrade and CO2 will come back into the atmosphere. So question, what could be the long term effect or permanent? That is afforestation. Why? Because this glucose produces those lignin, this type of thing which produces wood. So in this way CO2 directly converts into wood, and we know that wood could be stored many trees live more than 100 years. So this will be saying after that wood doesn't degrade initially. So it's a better to say it's a permanent way. And remember one thing, what was our earth's condition in the pre-industrial state or in the very ancient time? It was covered with forest, means it was, the CO2 was converted into wood and it was there, so there was no global warming or climate insecurity. So this is the permanent. But remember, when we have make huge damage, so we need to do temporary, permanent or other man-made or scientific technique to consume CO2 or remove excess CO2 from the atmosphere, and we should adjust the level into its original form. And that is the one of the target of Paris Climate Agreement. Although it doesn't say that we will bring it to the original state, no, we will reduce the global warming up to 1.5 or 2 degrees centigrade. Okay, now so we need to separate this excess CO2 from atmosphere, because this excess CO2 in the atmosphere is storing excess heat, and that's why we are facing global warming. Okay, and what actually data, if you look at the pre-industrial time, means mid up 1700, what was the level? The level was near about 280 ppm, and currently it is greater than 400 ppm. You will say that, sir, it's a ppm, means parts per million, means you were talking about the amount with respect to 10 lakhs. I say because this is student concentration, but if you consider the overall amount, then it is in gigatons. Okay, so remember this. Now you can say that, sir, in many places there are value differ. I agree, year to year this thing you may find different source, different data, different governmental survey, but remember it's actually gigaton scale. What do we mean by gigaton? 1 ton means, actually 1 ton is equal to 1000 kg first. Now mega is 10, so kilo is 10 to the power 3, mega is 10 to the power 6, and giga is 10 to the power 9. So 1 gigaton means 10 to the power 9 ton. So see how much CO2 we are emitting annually. So that's why our duty is to restore the planet by reducing CO2 level, because we are the major contributor for this emitting huge amount of CO2 in the atmosphere on a yearly basis. Okay, so now how to do that, or how to execute the target? So first of all, population control. Will say that, sir, what are you talking? Population, how population is controlling? Remember, what is the main reason for CO2 emission in the atmosphere? There are two main reasons. One is energy production, second is transport. So if we have more population, more energy requirement will be there, for example in electricity in household, or transportation, more car, more petrol, more diesel, like that. So, and another thing, more people means more land will be required for agriculture, that is for food production, as well as their living, means for their construction of home, like that. So it means they will destroy the forest in one direction and they will consume more energy. So both will ultimately result in enhanced CO2 emission. So we need to focus on population. how we are growing. And another thing, we need to control it. And unnecessary use of energy we need to reduce. We need to, since our main energy is coming from fossil fuel, so we should minimize our energy requirement. For example, if we don't need electricity or light or fan or AC, we need to switch it off as soon as possible. We should be more independent on energy utilization. Now focus on alternate energy source, because without energy we can't live. If you say me that, sir, can you live without a fridge, refrigerator, fan or light? No, I can't. So that's why we need to focus on other alternate energy source, that is hydropower, wind energy, solar, etc. But remember, I shall always try how to minimize the energy requirement, unnecessary use of energy. And most important thing you may consider is a biofuel. Why this is important? Because we produce a huge amount of agricultural waste, and that could be converted into alcohol, ethanol. And nowadays ethanols are considering a alternate and liquid fuel for cars. You may consider flex engine like that, or you can blend this ethanol with petrol and use in the bike, so such that the overall CO2 emission is less. Because since it's an agricultural product, means the ethanol's carbon came from CO2. How? Because plant did photosynthesis, produces glucose, and through other transformation that ultimately converted into ethanol. So that's why this CO2 is not a fossil fuel based CO2. It's a CO2 what was previously in the atmosphere, and plant did the separation and fixation. Now another thing, whatever we have already emitted, it's huge. So we are observing huge the climate change. Okay, so that's why it's also needed to separate the excess CO2 present in the atmosphere and utilize this for CO2 hydrogenation through electrochemically and others, or chemically, to produce methanol, methane, ethanol, etc., which we can use as a fuel. So that is the important. Now what is the biggest problem in this case? The biggest problem is the separation of CO2. Why? Because separation of CO2 in the ppm level, ppm means parts per million in 10 lakhs. 1 million means in 10 lakhs, how much? It's a very less. Whenever you see the chemical reaction, for example Grignard reaction, organolithium reaction, in those cases we use pure CO2, but in this case we are using a very low concentration CO2. That is the biggest challenge for CO2 separation from the atmosphere, because if you look at the overall contribution of CO2, that is around 0.03% or slightly more, means near about this concentration. So that is the biggest problem. So how can you separate selectively this much percent gas? But here one blessing is that the rest thing are nitrogen, oxygen and argon, which are relatively inert. So that's why you will say that, sir, oxygen is active. I agree, but heat needed, and not, if we utilize proper chemical method we can separate it. And that was done by this Professor Keith and its co-worker, and they published this thing in the manuscript Joule. So we'll discuss very briefly about this. The detailed engineering and cost analysis of CO2. Actually this process is for capturing CO2 from the atmosphere. So direct air capture, if you consider the value is this much amount, I shall come later about this thing. So what is the problem? If you do direct air capture, for example cooling, those kind of thing, you use huge amount of electricity, and we know how the electricity comes nowadays. Nowadays electricity comes from fossil fuel. So during the electricity production you are emitting CO2, and using that electricity you are fixing CO2 into something else. Is it that much profitable? Obviously not. And or please don't consider profit from economic point of view always. There are profit from many angle, and now we are focusing on the climate or nature, because if nature doesn't sustain, nature can't afford, then economy can't continue. So there is, I know, a huge conflict going on between economy versus environment, but we need to be smart enough to choose wisely. Now so in this case you can see a pilot plant's this pictorial representation. So what happens in this case? Here for example this is a air containing CO2. These fans will consume the air and it will emit the air with, you may consider, less CO2, means it will separate the CO2. How the process will carry out? So in air there is CO2, you can see here, and above means if you look at inside this there will be a liquid used. That liquid is nothing but a mixture of calcium hydroxide and KOH. Okay, so not exactly mixture, I'll come slowly. What happened at the initial phase, the liquid which will wash the air is not actually calcium hydroxide, it is a KOH solution. So what it will do, first KOH will react with the carbon dioxide present in the atmosphere, will produce potassium carbonate, and remember this potassium carbonate is soluble in water. Fine. Then at the second step, this solution will react with calcium hydroxide solution, and in this way anion exchange will happen and it will produce calcium carbonate. And why this will produce calcium carbonate? Because this is insoluble, so it will precipitate out and it will come out from the equilibrium, and in this way you can see the KOH is regenerated. Okay, so what in this case, what you can say, that this air is directly converted into this calcium carbonate, and in both cases this KOH will produce, will be further used for this air capture, means air to CO2 capture. And how the CO2 could be generated? This could be generated by heating of this calcium carbonate, which will produce calcium oxide and carbon dioxide. It's a pure carbon dioxide because this is solid material, this calcium carbonate. Okay, and this CO2 and this calcium oxide will again react with water and produced calcium hydroxide. For example, Indian student I know, they know that lime when mixed with water, it produces this calcium hydroxide, and this is, means for example people eat pan, so there such kind of this calcium hydroxide use. So those kind of thing means calcium reacts, what message I want to give, that calcium reacts with water very facile with exothermic reaction and produces this calcium hydroxide. Now question, where is the problem of this process? The biggest problem in this process is, student, this step, calcium carbonate to calcium oxide production. Why? Because this reaction needs a very high temperature, more than 900 degrees centigrade. So that is the biggest problem. Why biggest problem? Why can't we heat 900 degree? Obviously we can, but remember, what is the energy source of our modern day? That is a fossil fuel based electricity. So their CO2 emission is occurring. So that is the biggest problem. Now consider, in future we became self-sustained in solar or other geothermal, hydroelectric, etc. thing, and we are producing surplus energy, means we are generating surplus electricity, for example using solar. Then what can we do? We can utilize that energy to produce this 900 degrees centigrade temperature, and we can, in this way, this overall chemical scheme presented in this slide will be economically viable. So the biggest problem is the source of electricity, which is fossil fuel. At the time we will switch from this to a renewable source, then the picture will be easier and we will be able to separate this CO2. And what is the use of this CO2? What is the use? This CO2 could be used in many industries, or it could be used for reduction into fuel. We shall come slowly this thing. So this is the overall discussion, and thanks for watching. And if you really enjoy my content, please subscribe my channel Chemistry, the Mystery of Molecules, and please encourage